Okay, so on this particular section, 12.3, up until this point, we have been dealing with sequences and series. The first section I gave you was just kind of a random thing where it was all the different patterns. We had to try to look at it and go from there. Then the last couple days we've been dealing with adding and subtracting specifically, right? If you notice where it was always adding the same number every time or minusing the same number every time, what do you think I'm going to do now?
Different numbers.
Multiply and divide, right? Exactly. These are known as geometric. Sequences or series. Okay? And again, the difference is the series is added, the sequence is not. So the directions are going to look very much the same. They're going to give you the same types of problems. You're going to have to find the rule. You're going to have to plug in. You're going to have to find the sum of all of it. This is almost going to be a carbon copy of all the arithmetic ones that you've done the last 2 days. The only difference is we're looking for what number are they being multiplied each time or divided each time instead of added or subtracted. Okay? The general rule for a geometric one is a sub n equals a1 times the ratio to the n minus 1. This number means common ratio. This number is your first term. Now, to finding the common ratio, what you do is you take consecutive terms and you divide them. What I mean by that is if you know the first term and the second term, you take the second term divided by the first term. If you know the 19th and the 20th term, you take the 20th term divided by the 19th term. As long as you have consecutive ones, no matter where they are, you can find the ratio by taking the larger term divided by the smaller term. Every time. So the first couple of equations are going to look like this. It's going to say 1, 4, 8, 16, 32, blah, blah, blah. It's going to say, tell me whether this is geometric or not, and explain why or why not. You had to do this with arithmetic, now you're going to do it with geometric. And here's how you do that. You take consecutive terms, like I'm going to take 4 divided by 1. The second term divided by the first term. What's 4 divided by 1? Right. It's 4. Nice. Now I'm going to take another set of consecutive numbers. So, Jacob, give me another set of consecutive terms up there. 8 and 4, right? The next two. The third divided by the second. So 8 divided by 4. Jacob, do you know what 8 divided by 4 is? 2. Now I'm going to ask you a question, Jacob, because I value your opinion. If I have 4 for the first one and 2 for the second one, if I told you it's supposed to be a common one being the same, can I throw this out, or do I have to keep going? I can throw it out. It's not geometric anymore, is it? This is not geometric because of the fact that we are not multiplying or dividing by the same number every time. It is a different number. Okay? Let's look at another one. 4, 16, 64, 256, oops, and 1024. Shaylin, give me a pair of consecutive numbers you want me to test. Which two numbers do you want to use? There's no 2 up there. 4 and 16. So the second one and the first one? So 16 divided by 4 is what? 4. Alyssa, which 2 do you want to use? 64 and 16. 64 divided by 16 is what? Anybody know? 4. Ruh-roh. We've got 2 in a row. Harrison, what's another set? 1024 and 256. As long as I'm consecutive, and if they are the same, if it is a geometric sequence, I should be the same, right? No matter where I am. What is 1024 divided by 256? 4. And guess what? We did it 3 times and it was 4 every time. Is this geometric? Yes. Okay? Yes. Why? We're multiplying by 4 every time. That's what's happening. So if they ask you for the next number, I would have taken 1,024 and times it by 4. Done. Now, a lot of times it's not necessarily going to be a whole number like that. What if it would have been a fraction? What if it would have been multiplying it, or if you would have reduced the thing and it would have been 1/5? That's the same as dividing by 5, but we write it as times by 1/5, just so that you guys understand that. So if they would have given you a ratio or a thing like this where it would have said 625, 25, 5, 1, if you would have taken the consecutive ones, 25 divided by 625, the trap is most people just put 5. But that's not what's happening. You're dividing by 5. When you divide by 5 or whatever, you're actually multiplying it by 1/5. Okay? So my ratio in this case would be 1/5. So be very careful with that because that's tripped up some people in the past. Okay? What do you think so far? All right. Then, from there, the problems are going to look like this, where it will say 6, 18, 54, 162, ... And it will say, write the rule. Then find a sub 7. Now yesterday and the day before, you guys were doing like an a sub 20, a sub 10, where you put those numbers in. If you're going to put big numbers in here, these answers are going to get ginormous. Do you guys know why? We're multiplying, right, instead of adding and subtracting. There are going to be some ginormous numbers with some of these. So, writing the rule. What's the first term? 6. The general rule, remember I gave you a little bit ago, was A1 times the ratio n minus 1. You told me that the first term is 6. That's good. Now what's the ratio?
3.
How'd you get that?
18 divided by 6.
18 divided by 6. Or 54 divided by 18. Or 162 divided by 54. They're all 3, right? That's the general rule. Now what do you do when it says find a sub 7?
Sub 7 for n?
Yeah. So 6 times 3, 7 minus 1. What's 7 minus 1?
6.
Okay, now here's where some of you have messed this up in the past along with all the other students. Knowing the order of operations that you have done since elementary school, 3 times 6 does not occur ever in this problem. 3 to the 6th is the first thing you should do. Remember, exponents come before multiplication and or division. So 3 to the 6th should be the first thing, and then I multiply that by 6. Now, your calculators that you guys are using, could I just type it in the way it looks, and will it handle it?
Yes.
Yes, because your calculators know and understand the order of operations. So what is 6 times 3 to the 6th?
4,374.
Okay, good. Thank you. So those are your 2 answers. You wrote the rule, and you found the 7th term. Does that make sense? Answer me this. Is this very similar to your arithmetic ones? Just a different formula, but it's the same kind of setup. Then after that, it says, I'll give you a little bit harder one so you can see what it looks like. A sub 3 is equal to 75, and the ratio is 5. The directions for this one, I was going to say, write the rule for the nth term of the sequence, then graph the first 6 terms. Again, just like the arithmetic ones, I'm not asking you to graph these. So all you have to do is write the rule. Okay? So, in that rule formula, the generic one, we had a sub n, a1 times r to the n minus 1. This number is your r. So I'm going to replace that right here with 5. Does it anywhere up there whatsoever give you what A1 is? Fisher? Does it? Where? No. You were right the first time. No, you were right the first time. It doesn't give it to you. Does it say A1 equals this? No. You were right the first time. Okay? The A sub n refers to the number that you get out after you plug something in. Does, Abby, I'll let you try to recover. Does it give you an A sub n, a certain one? Yeah. What number is that? No. What number do you get out after you put in? It's the 75, right? So that's where the 75 goes. Now, Abby, the 3 is going to go in for the number. So where is that going to go? The n. Very good. There we go. Yay, Abby. So proud of you. Tear. Okay, so what has happened is after some prompting, this number tells us what number we would have gotten if we plugged in 3. That's what this says. This goes in for the A sub n. This goes in for the n. You put the number in for the the ratio, and now we clean it up and find A1. What's 3 minus 1? 2. Right. So we got 75 equals A1 times 5 squared. What's 5 squared, Madison? Try again. 25. Yay. So 75 equals 25 times A1. Do you know how to solve for A1, Madison? Nope. Not subtract. I don't get rid of multiplication by subtraction. I don't get rid of multiplication by adding. Divide. There we go. There, right. This one's a little bit different than what we have been doing. Remember the last 2 days we've been dealing with getting rid of by adding or subtracting the number, right? Well, this is being times. So the opposite of multiplication is division. What's 75 divided by 25? 3. So here's my final answer. A sub n equals, what was the first term that you just told me? 3. What was the ratio that the problem gave us? To the n minus 1.
So would 3 be an answer, or is just the equation the answer?
The equation is the answer, because it wants you to write the rule. Okay? Then, after that, comes the harder ones. A sub 3 equals 10, and A sub 6 equals 270. When we had these in the arithmetic ones, this is where we set up the 2 different equations and we used elimination to get rid of it. The first thing that you need to do is you need to rewrite those as if they were being plugged in. Remember, the 10 is the number that you're going to get out. Does it give you A1 at all anywhere? No. Does it give you the ratio anywhere? No. Does it give you what number you're plugging in? Yeah. So what we're going to try to do initially is we're going to try to set them up in this type of situation. A sub n for the one over here on the left is 10. I do not know A1. I do not know the ratio. And 3 is going into the problem. Callie, what's 3 minus 1? Awesome. Good job. So I've got 10 equals A1 times R squared. Okay. Thanks, Callie. On the right-hand side, when I plug it in, what's the A sub n number that we need to put in? 270. Good. Equals, I don't know what A1 is, times the ratio, which I don't know. But what number am I plugging in there? A 6. And what's 6 minus 1? So here's what I have. This is similar to my arithmetic ones. The only difference was now I used elimination at that point. If you try to use elimination here, it is not going to work because there's not adding or subtracting in between the two terms. It's just multiplication. So if you try to use elimination, it ain't going to work. So what you have to do is you have to take either one of these equations and solve for one of the letters. We're going to use substitution. My suggestion, always choose the one that has the smaller exponent to solve for. So that means the one that is here on the left that has r squared, I'm going to solve for a1. That's what I'm going to do. All the time. Every time. I'm going to solve for a1. So I'm going to divide by r squared, divide by r squared. Because, as Madison told me, getting rid of multiplication, you divide. The r squareds cancel out, and you're left with a1 equals 10 divided by r squared. Once I've done that, Miss Wright, if I have a1 equals this group, where do you think I put that? In the other equation, right. That's the substitution property. All I'm going to do is I'm going to take that stuff that we just solved for a1 and I'm going to stick it in the other equation for that letter. So what's going to happen is I've got 270 equals 10 divided by r squared times r to the fifth. I took out the a1 and I put in what we just got it to equal. Exactly what Abby just told us. Now, what happens is, do you see how you had r to the fifth on the top and r squared on the bottom? If I have 5 on the top and 2 on the bottom, who has more, top or bottom? The top by how many? 3. Good. So what you did was you subtracted exponents. That's a r. Now, Skylar, what do I have to do to solve for r? Divide by 10 is right. Minus the So 270 divided by 10 is 27. Hey, Michaela, do you remember how to get rid of r cubed? Cube root it. How do you do that? Don't remember? Yeah, no. When you cube root, remember that means you're going to put a 3 in the crack. And if you break it down, remember you're looking for groups of 3 of the same thing. On your calculators, you would hit math, and then it's option like number 4 or whatever. Right? And then you type in the cube root of 27. Does anybody know what the cube root of 27 is? What number multiplied by itself 3 times gives you 27? 3. Good. So my ratio is 3. Hey, once I know the ratio, can I plug that back in to find a1? Yeah. What's 3 squared? 9. What's 10 divided by 9? 10 divided by 9. You can leave it like that. Or if you want to write it as 1 1/9, or if you want to write it as 1.1 repeating, that is totally up to you. So you found your A, you found your R. Now it's time to actually write the physical answer. A sub n equals, what was the first term? What was A1 that we just found? 10 over 9. What's the ratio? I am only going to give you 2 of those. That is the process that you have to take to get them. Those should be your 2 hardest ones that you have today. Okay? I promise. In all my years of doing this, especially with Algebra II students, the ratio for this, when you have to cube root or whatever, I have not seen a whole lot of them come out as decimals. If you're a college level class, yeah, probably. But when you cube root a number, it's going to probably come out nicely, or fourth rooting a number, it'll probably come out as a nice number rather than a fraction or a decimal. Okay, with high school students, I haven't seen too many of them that are messed up that way. Okay.
How did you get the 10x?
Right here, where we solve for A1, I put 3 in for R because 3 is what we found. So what I did, Brianna, then was when you have it going into here, 3 squared is 9, and 10 divided by 9 is 10 ninths. Okay? Then, the last thing that you're going to use is you're going to use this formula. S sub n equals A1, 1 minus R to the n, over 1 minus R. This is to sum a finite geometric series. Okay? Finite meaning what? No, that's infinite. Finite is when it stops. Right. Just think about these numbers as they continue to grow. Are you going to ever be able to add all of them together? No, not always. So, what's A1 stand for? First term. What's the R stand for? Ratio. What's the N stand for? Number of terms. And that's all you need to know. You need to know the ratio, you need to know the first term, and you need to know how many terms you're going to add together. All right? Okay. So here's how they're going to look. Did you get it here? Did you get it? Yeah. Okay. You're going to have the E thing, and we'll go n equals 1, and we'll go 18. What are your options? Your options, as you're writing this down, one of the options would be is to put in every number from 1 to 18 and then add them together. Do you want to take the time to do that? You can. It's not wrong. It's just going to take you a long time. But the first thing I need to know is what the first term was. So how are you going to figure out the first term? The answer's not 1. Huh? Plug 1 into the formula.
Yeah.
Right. Why are we putting 1 in there? That's the first number I want to put in. That's the bottom answer, right? Or bottom thing. So if I do that, I have 4, parentheses, 3, 1 minus 1. Fish, what's 1 minus 1? What's anything to the 0 power? So I end up with 4 times 1. What's 4 times 1? 4. Abby, can I point out something to you? And I don't know if you saw this, and I don't think too many of you did. But A sub n equals A1 times the ratio n minus 1. Now look at the equation. Do those places, those spots match? Now you told me to put 1 in there because 1 was the first number, and that's what we got for the first term, wasn't it? Okay? So in that case where it starts off with 1 like that, that's going to happen. Okay? What's the ratio then? What's in the R spot? 3. 3. So I've got A1 is 4. R is 3. How many terms am I summing, Tasha? 18. Holy cow. So my N is 18. Do you have your calculator, Tasha? No? Somebody does. Reese does. So if I look at my formula said A sub n. No, it didn't. What did the formula say? A sub 1, right? 1 minus the ratio raised to the n power. 1 minus the ratio. The first term was 4. 1 minus 3 to the 18th. 1 minus 3. So all I did is I plugged everything in. Now, I want to point out something to you because you guys are going to screw this up, because you guys did, some of you on the assignment. When you get this number here, negative 3 to the 18th power is different than negative 3 to the 18th power. And the reason why I say that is because is the 3 in parentheses with the negative sign? No, it is not. If you type it in there as, and it's supposed to be a negative on the outside, that is saying technically 1 minus 3 to the 18th. 3 to the 18th needs to come first before you subtract. You guys know the order of operations. But what happens is that you put it in there and you get positive because it's an even power, and then you end up with the wrong answer. So what I'm trying to say is be very, very careful about how you plug this in. Then, this is going to be a big number. So if you get a big number on this and you think I did something wrong, chances are you probably didn't. So first thing I want to know on the bottom, let's just clean it up. What's 1 minus 3? Negative 2? What's 1 minus 3 to the 18th? You can type that in the way it looks. Negative. Just tell me the digits and I'll write them down.
387 420 488.
Right? Then I want you to take that big giant number that we just wrote up there, 387420488, divided by negative 2. Then times it by 4. And once you do that, that's the sum of that series. It's a big number. Anybody got it?
And that's the answer.
No? Well, you got to, did you do the divide by negative 2 and times it by 4?
Yeah.
Yeah, and that's the answer. What is it?
So 774 840
Hold on, 774.
840 976.
That's 774,840,976. Now, that looks like a big number, and as it should be, because as Tasha pointed out earlier, we're multiplying, so our numbers are going to be bigger. Think about it. We were adding 18 numbers together that were being multiplied each time. Is it going to be a bigger number? Absolutely. That's why you have calculators to help you. It's not going to be where you're going to probably be able to do these in your head right away, like you could with the arithmetic ones. All right? Be very careful about how you type that into the calculator, because that could get you in trouble if you don't. So, with that one then, just so that you know, we're on page 814 to 815, 4 to 52, multiples of 4. I know it sounds like a lot, but it's really not.